Hello everyone, welcome to my YouTube channel. In this video, I am going to explain how to conduct IIT virtual labs. Okay, for this video here, analog circuits virtual lab is used. Analog circuits virtual lab is used. Okay, so this is analog electronic circuits virtual lab. So here this window is displayed. Welcome to Analog Electronic Circuit Virtual Lab. So this is designed by IIT Kharagpur. Okay. So this is introduction. So what is the significance of virtual lab? Virtual lab for teachers and a virtual lab for students. What are the features of virtual lab? All these are available in introduction. Okay. Anyhow, the important one is list of experiments. So click on list of experiment. Here list of experiments are displayed. The first one is the basic functions of oscilloscope and function generators. Okay. And second experiment is active filters. Third one is monostable multivibrator. And fourth one stable multivibrator. Fifth experiment is Smith trigger, and sixth experiment frequency response of common source amplifier, and seventh experiment is digital to analog converters. These are the experiments available in analog electronic circuit virtual lab designed by IIT Kharagpur. Okay, so I will explain how to conduct experiment with the help of one experiment. So for this I choose monostable multivibrator using IC 555. Okay, so this is the objective. So objective of the experiment to perform monostable multivibrator and observe the input voltage, output voltage and capacitance voltage and calculate the pulse width both theoretically as well as the practical. This is the basic objective. Here quiz also available. Okay, and theory also available. So this is the theory. Okay, so what is 555 timer and pin configurations and everything available in theory. So this is the circuit monostable multivibrator using 555 timer. Just observe this circuit. 8th pin and 4th pin is connected to plus VCC. Okay, 7th and 6th pins are short circuited. Here capacitance voltage is applied. Again plus VCC is connected to this resistor and output is number 3. A capacitance is connected between the pin number 1 and pin number 5. So the pin number 1 is ground. Pin number 1 is ground here. Okay, this is basic theory and input waveforms, output waveforms, applications of monostable multivibrators, all these are available. Okay, so now procedure. So this is procedure. Here first point is how to connect the connections L1 to L12, L14 to L12, L16 to L12 like that connections. Second point how to check the connections. And third point what to do if wrong connections are occurred. And fourth point related to particular experiment, how to set this RA value, capacitance value, supply voltage value, trigger input values, all these are available in procedure. So everything is available in procedure. Okay, so this is the also available model circuit with connections. Okay, the most important part of this experiment is simulator. This is very important. Okay, so click on simulator, will get monostable multivibrator, and again click on monostable multivibrator. So this is the actual part of the experiment. Okay, so here in procedure connections are available, so same will be continued in simulator also, same will be applied. So pin number 8 is connected to VCC. Okay, and pin number 4 is connected to VCC. Here L10, this is L10, it's not a pin, L10. L10 is connected to VCC. Okay, and 7th pin is connected to L11. Okay, 6th is connected to 13. So here 11 and 13 are shorted, and pin number 1 is connected to 12, ground. Here this is ground. So okay, so 5 is connected to 15. Here 16 is connected to 12. Okay, and 14 is connected to 12. Okay, so these are the connections. No worry, these connections available in procedure. How to connect the circuit. So that is the first point of procedure. Now click on check connections. So here wrong connection. Okay, so one connection is missing. Pin number 3 is connected to 17. Okay, so now again click on check connection. So here right connection. Okay, now set the resistance value. For example, say resistance is equal to 10k. Just observe here resistance value RA is equal to 10k. Just drag this one. So you'll get 10k. Okay, resistance in the order of 10k. So here the capacitance. Capacitance is equal to 1 microfarads. Capacitance is in the order of microfarads. Here capacitance value is equal to 1 microfarad. Now the supply voltage VCC. This is VCC. So here VCC is set to 9 volts. VCC is set to 9 volts. VCC is set to 9 volts. So here the VCC is set to 9 volts. So here in monostable multivibrator, trigger pulse is applied to pin number 2 internally. Okay. Okay, that is not shown in the simulator, but actually trigger pulse is also applied to pin number 2. But here the internally trigger pulse is applied, so you have to set the time period of a trigger pulse T in 20 seconds. Okay. Now calculate. So to get theoretical values, so this T out is very important. This means the pulse width duration. No need to bother about T off in monostable multivibrate. Just pulse width is enough. Okay. So calculate. Click on calculate. We will get the pulse width 11 milliseconds. Okay. 11 milliseconds. So here resistance is equal to 10, capacitance is equal to 1, 10 into 1 into 1.1. 1.1 RC is the pulse width of monostable multivibrator. So resistance is equal to 10k and capacitance is equal to 1 microfarad and formula is equal to 1.1 into R into C. Obviously we'll get 11. Okay. So theoretical value. Now coming to the practical values. We have plot the output voltage. So this is output voltage. So the amplitude, just observe the amplitude 9 volts. Okay. And pulse width is exactly pulse width is 11. So practical value is 11 and theoretical value also 11. Amplitude VCC. Okay, amplitude VCC. Model waveforms also available in theory. Okay, right? So this is the width of the pulse. Okay, so now I will plot the trigger input voltage. This is the trigger input voltage. So this is negative going trigger, a very short span, just 5 seconds, but overall is 20 seconds. Overall is 20 seconds. Okay, so this is the trigger input voltage. Again, trigger input voltage also amplitude 9 volts plus VCC. Okay, all these are available in theory. So now voltage across capacitor. So for this experiment, the maximum voltage is 2 by 3 VCC. Here VCC is equal to supply voltage, that is equal to 9. 2 by 3 VCC obviously will get 6. So 2 by 3 into 9 is equal to, will get 6. So every 20 seconds terminated, again capacitor starts charging. Again 40, again 60. Just observe the capacitor waveforms. Okay. So the main objective of this virtual labs is to improve the designing skills. Okay. So for example, I want to change the resistance and resistance value. What will be the output? So clear. Click on clear. So connections are same. Now I will change the resistance value. Just observe here resistance value. So instead of 10k here, 5k is adjusted to 5k. Now capacitance is equal to same 1 microfarad. Calculation purpose here 1 microfarad is used. And supply voltage is equal to 9 volts. Okay, here the supply voltage is equal to 9. I want to change supply voltage also 12 volts. Okay, 12 volts. VCC is equal to 12 volts. Now the time period trigger by default it is generally 20 seconds. Okay, 20 seconds is enough. Now calculate. Here capacitance is same, resistance value is changed. So instead of 10K, here 5K adjusted to 5K. So just calculate, theoretical value will get 5.5 pulse width. Okay, exactly half of the previous example. Okay, right. Now to plot the output voltage and choose output voltage and plot the output voltage. Just observe the waveform. Here VCC is equal to 12 volts and pulse width is equal to 5.5. Okay, so for every 20 seconds again this pulse is generated. This one is generated, but pulse width is equal to 5.5. Just observe the pulse width 5.5. VCC is equal to 12 volts. Here also VCC is equal to 12. Okay, 5.5 pulse width. This is 25.5. So 25.5 minus 20, that is equal to 5.5. So this is the first circuit waveform. This is the second circuit waveform. I mean second circuit parameters. So here now again clear. I will change resistance value. For example, say resistance is equal to 3K. Okay. Capacitance 1 microfarad and VCC is equal to maximum 15 volts is applied. So this is VCC 15 volts applied and trigger input is equal to 20 seconds. Trigger input is equal to 20 seconds. So now click on calculate. We'll get 3.3 pulse width. Okay. Now click on output voltage. So this is the output voltage, third circuit waveform. Okay. So here VCC is equal to 15 volts. So and the value is equal to 3.2. Theoretically we'll get 3.3. Practically here 3.2. Okay. 3.2. So pulse width is very small. Why? Because resistance value also decreases. Okay. So this is third circuit. Just observe the voltage across capacitance. So this is the voltage across capacitance. This is the capacitor. So now plot the voltage across capacitors for different values. So just observe the voltage across capacitor. This is the first one. 2 by 3 into VCC. That means VCC is equal to 9 volts here. 2 by 3 into VCC 6. And second circuit 2 by VCC is equal to 12. So 2 by 3 into VCC. So obviously nearly 8. So we'll get here 7.92 like that. And fourth one 2 by third one 2 by 3 into VCC. So 2 by 3 into 15 we'll get here 10 volts nearly. So different waveforms. So what I'm trying to say is very clear. Based on this virtual labs, designing skills will be improved. So thank you all.